Hi, welcome everybody to my talk. My name is Alexander Zeitler, and today I want to show you why MVC, specifically ASP.NET Core MVC, is still a good choice for web applications. And maybe you will see some tricks that make it a bit more common for these days. So, just to begin with a little story. I have been a Microsoft product person since the 90s, and around 2010, I have been using very early builds of ASP.NET Web API, which was the first Microsoft library for building REST APIs, and I have done single-page applications with Knockout.js. So it has been very early days of all that SPA and Web API story. And by 2014, I decided I didn't want to use Windows any longer because, I have been using macOS on the side and Linux, and it felt more comfortable for me. So there was an issue. I have been doing .NET since the early days, since 1.0. And I had to look for another stack because .NET Core wasn't born yet, or not ready at least. And it gave some delays, some may remember. So I decided to move on with Node.js and do sparse using Angular and React. During my journey until 2020, in the middle of the pandemic, I rediscovered some parts of .NET. I played around with F#, and during my days on Node.js, I have been starting with event sourcing. And there were some good parts about Node.js, and there have been some not so good parts about Node.js. And somehow I felt I'm missing something. And I took back a look at .NET, and it has been very major at that time already. Speaking of .NET Core, of course. And I was thinking, wouldn't there be something that made web development, especially web application development, more easier than it has been in the past? So I was remembering, okay, something like web forms might not be the right choice, but MVC, which I have been using before 2010, it might be a good choice again. So I played around with it, and I also quit my job at that time at 2021 and decided to start a side hustle. That's a bit of introduction to lay some context for you why we're here today now. And I decided to do a side hustle because, getting free money got a little bit harder. So no VC capital was the goal. And I think it's even harder for somebody to get started in building something new if you are not having some AI stuff baked in these days. So on the other hand, bootstrapping and indie hacking is on the rise, which means you have an idea of some product, of a problem you would solve. And most of the times this is solved by, or started at least by, a single developer who maybe build a team if it succeeds or may not. But you will start without VC money, and you have a decision to make or buy. So you either have something that very grown up at the start. Speaking of your platform, maybe .NET, maybe Rails, Go, whatever. And if you don't want to build forever, you either have the option to have something which is integrated out of the box, or you have a community which is building a lot of stuff, but it also may mean that something could be abandoned at some point in time. And what I discovered as well is simplicity is also a key element of being able to bootstrap something on your own. And I felt like if I'm doing it the way I did application development in a larger team, like building web APIs first, building some single page application and replicating tasks on the client side and on the front end and on the back end side. This is not a good option to bootstrap something on your own. So what is on top is deep work is pretty hard these days. So we have notifications from our phones, from our tablets, some classics like emails. There's some constant stream of distractions. We have meetings, useful or not. And on top of that, if you are going to do a side hustle, you might not do it full time, at least at the beginning. So you have very little time, and that's some aspects of as well that played a role in my decision making. So what's also interesting, JetBrains had a poll a few weeks ago, and they ask, how often do developers get in a flow state? And as you can see from the numbers, so it's ranging from almost always to rarely. And if you look here, you can see that almost or exactly 40% at part times actually getting into a flow state when building applications or doing their work in general. So yeah, that's how I rediscovered ASP.NET Core MVC. And as I already mentioned, if you're building something on your own and alone, you want something that's batteries included. So I think .NET and ASP.NET Core is a great fit here because it has a rich .NET-based class library, and MVC has a battle-tested view engine, Razor view engine with layout and partials and HTML helpers. You can have conditions, you can have lists, whatever. So it's grown up, and it also has identity as an option you can activate and configure it. You can have cookie authentication. You can throw it into OIDC and single sign-on and so on. It comes with localization. It comes with globalization. That's all stuff. When you are looking at social media, you are told don't build that on your own, and then you are tricked into, hey, there's a SaaS that offers this, and it offers free for beginners. And at some time, you get your first bill, and then you notice, oh, that thing that ran for a few months and is running now costs me more money that I'm getting from my customers. So that's another aspect. What I think is that inside that complete framework, ASP.NET, and it's a huge advantage. And I get that .NET or ASP.NET is sometimes a bit, not considered the real thing or a good thing outside from the Microsoft bubble. But I think it's truly estimated. And as you can see, if you look at other platforms, for example, Node.js, there's Bun at the moment, which is having a lot of audience they are doing something similar. They are trying to provide an alternative runtime to Node.js and include more stuff that Node.js had included. And it tries to be less build intensive. It tries to include TypeScript support and such things. Same for Dino, for example, or Next.js. It started with something more on the front end, and then they started to go back to the back end. And it's like, hey, SSR, server-side rendering, is all the rage in the community in Node.js. And my first thought, okay, and that's what we had 20 years ago already. So you can also see there is some stuff that looks very similar to ASP.NET Core, which is built in right now into new stuff. So I guess there's not everything wrong with ASP.NET Core and ASP.NET Core MVC. So yeah, you might ask, why not Blazor? So yeah, I took a look at the .NET 8 docs, and the part about ASP.NET Core MVC has about 200 pages, and Blazor docs as of version .NET 8 have about 1,400 pages. So there's a whole lot of stuff to learn if you want to get into Blazor. It has different render modes and all that stuff. And what I wanted to have was something very basic, and I could opt in with more complexity if required. So I could start with a focus on the problem I wanted to solve pretty much on the core of the domain of the business instead of learning new tech. I wanted to use something I am familiar with. Of course, this comparison of 200 pages versus 1,400 is not quite fair, because there's a lot of stuff outside of the MVC part, like, for example, tech helpers and such stuff, or some razor knowledge that isn't part of this MVC part. So it's actually a bit more to that, but you can get the gist of it. So now I'm interested in what's your application stack, and we have prepared a poll, and you can choose to have ASP.NET Core MVC and Razor pages, so quite traditional approaches, or the new Blazor approach, or you can choose from single page application, Angular, React, and this also means you're building web APIs using ASP.NET, because I guess that's why you're here today. You're building something using .NET. Maybe I forget something, and then you can choose something else from the poll. Okay, so you might say MVC sounds quite nice, and there's some cool stuff about it, but one thing is, it's a monolith. And that's where we want to dig a bit into MVC and how we can use it in a different approach. So when we look at MVC, what we have been taught, it's pretty easy. It's model view controller. That's where the charts come from. And it says the controller manipulates the model. If we are going from over here to the model updates the view, and the view sends the user input. And that circle can turn forever. And of course, there are variations, but that's it in a nutshell, of course. And then we now will have a look at what we have made of it, because if we just go a little bit back again, there's nothing about a structure in an application or in a solution. For example, if you think in .NET, because MVC is not only available in .NET, it's available in Rails, and it doesn't really make some assumptions from the diagram here about how you structure your stuff. So let's go to a typical solution and some typical application that is a to-do application. And that's what you get when you start a new MVC application using .NET Core. May it be from the command line, or may it be in Writer, for example. And you have a to-do controller, you have a to-do model, and you have a to-do section with views, create, edit, and the index view, for example. And our to-do model might look like this. I have left away annotations, for example, for entity framework to keep things simple, but you can guess that there might be some attributes, for example, for identity and stuff like this, to describe our drug model for entity framework. Okay, and that's quite a bit for a simple to-do application. So we can have a title, we can have a description, and we can have a state represented by is complete. And we will have some sort of metadata like created at or the due date and the completion date if we set it to completed. And then we have the views on the left hand here. We have the add to do view or create view as it was named. And we have some labels and some inputs so we can enter the data from our model. So it's title, description, and due date. That's required to create a new to do. Other stuff like created on will be set from the controller, as we will see. So that's adding or creating a new to do. On the right hand side, so we have the view to edit it to in existing to do, and we have title and description, so we can change it. We can also maybe edit the due date, and now we can also set the is complete state. So we will get a checkbox and we can update the to-dos. Both views share the same model as we have seen. So it's up to us to set the right properties or provide access to those properties in our views. And then there's a controller, and just ties all the views and all the functionality together. So we have an index view. It's an overview where all our to-dos will be displayed in the current state. Maybe there might be only the active ones, or maybe the completed ones might show up for maybe just 2 days after they have been completed. So I can reopen them, for example, or something different. But all these features might make our model a bit more complicated, and we might have to add properties. So that will play quite a role in the rest of this talk. And then we have a create method or action, as it's called in MVC, that is providing our form. That's the first one. And the second one will allow us to persist it in the database or wherever. Then we have that second part, that's the edit. And we can first do a get for that view, so we can show what we are editing, and then the actual edit is done via the HTTP post, and we can update our to-do. And if we want to, maybe we created it by accident or whatever, so we can delete the view, a to-do. And then there's something we always had in .NET, and I'm not sure it's a problem in other platforms that got that much attention. And the problem we always cared about, or not to say we have been scared about, has been coupling. So when your application grows, you won't have stuff to be decoupled. And what's coupling actually? So in software engineering, coupling is a degree of interdependence between software modules, a measure of how closely connected two routines or modules are, the strength of the relationship between the modules. Coupling is not binary, but is multidimensional. So that's what Wikipedia says. Wikipedia says a lot more about it, but that should be enough. And the problem with coupling is that it has been fought for maybe 10, 15 years in ASP.NET and also .NET in general. And yeah, it's the question: how many IOC containers did we have in .NET since then? Because that's how it has been solved in .NET, and there have been a lot of other things, practices, principles, patterns that we have used to make the coupling as little as possible. So we started and made our code clean. Then we made it solid. We said, okay, we need a single responsibility principle, open close principle, and all that stuff. That was all around decoupling applications and make them as loosely coupled as possible. But in the end, maybe we tried different architectural styles. So we said, okay, let's try layers. That has been in the early 2000s. And the idea was, if we can only access the layer below our current layer and not from a lower layer up to a layer above, we will have less coupling and we will have some sort of direction. So it went from presentation to business logic to data access and into the database. And we had some so-called cross-cutting concerns, logging, monitoring, and security. And yes, that had been the style of applications until maybe 2008. Maybe it's even today. I don't know. Well, it didn't work out well, and then we tried hexagons and said, okay, let's build a hexagon and have a core of our application, which is inside the smallest hexagon. It's the application core. And then we can have a shell around it with business events and administration and persistence and notification. And then we have these adapters, and that's been the support and adapters architecture style. And something quite similar to it has been clean architecture. Instead of circles, I would almost say it's hexagons. So again, we had entities, our application, our enterprise business rules inside that core. And then the first circle around it was application business rules. Then we had interface adapters, again, adapters. And then we had framework and drivers. So it looks quite similar. And we had some flow of control, which can be seen here. So all these styles, when you have been looking at it, it was mostly about decoupling and testability and all that stuff. But in retrospective, it feels a bit like we didn't see all things, or we missed something, and that's cohesion. That's one of the things that has been talked rarely about it. The interesting thing is that if you look at Wikipedia, cohesion is mentioned in the coupling article or post on Wikipedia, but somehow it's got never mentioned or rarely mentioned. So in computer programming, cohesion refers to the degree to which the elements inside a module belong together. In one sense, it's a measure of the strength of relationship between the methods and data of a class and some unifying purpose or concept served by that class. In another sense, it's a measure of strength of the relationship between the class method and the data. So we will have a look at some pulling forces, and which these forces are coupling and cohesion. And you can have loose coupling and high cohesion, which is good, or you can have high coupling and low cohesion. And if you look at here, so we have only one connection, and there's a loose coupling and a high cohesion on that side. And high cohesion means that the parts that belong together are contained in the left box. And the same applies for the right box. And because there's no much connection between, they are loosely coupled because the right parts are in the right box, to say it. And quite the opposite is the parts are shared between the left and the right box, and that causes a quite chatty interface between those both boxes. And that's when you zoom out a bit, these boxes are business context or business rules or something. You may name it as you like. So if you name it bounded context, for example, or aggregates, for example, if you don't design them well, you will have much interaction between them, and that's this high coupling and low cohesion problem. Another thing is when we are navigating code, maybe we are joining a team as a new developer, for example, we need to read code. And every time we want to add a new feature or modify or expand a new feature, first we need to read the existing code. And that's what Matt said in the first talk today. We are reading code much more often than writing it, actually. And thanks to AI, it will be even less what we are writing. So it's about finding the right zoom level at some code. And there comes in another thing. It's named locality of behavior, and it's been defined by by Richard Gabriel in his work named Patterns of Software. And locality of behavior says that a unit of code should be as wide as possible by looking at only that unit of code. The primary feature for easy maintenance is locality. Locality is that characteristic of source code that enables the programmer to understand that source by looking at only a small portion of it. So what does it mean? If I have an application, maybe some enterprise resource planning tool, some CRM, for example, that's a huge piece of code. And now I should change some small parts of it. And if I have to look at a lot of places, I can't get the behavior easily, what the code does, how it interacts, classes, methods, functions, for example, modules. And that's a problem. Let's look at example clean architecture application, and I'll explain it a bit more. It's not to blame clean architecture or something. It's like how .NET applications have been built like forever. We have a lot of solution folders, projects inside it. And this sample application actually is a to-do application. So we have 8 projects to build something like a to-do applications. Why is it a problem? Problem comes in, as I already mentioned, is if I want to change something or if I want to add a new feature. And speaking of this, clean architecture to-do application, if I add a single property in that update to-do item, I have to change 7 files, and that's without the views. And I guess that's quite a problem, because if we look at it from another perspective, that's from the recent files dialog in Rider. And I had to split the solution tree into 3 panes to get it on my screen even. Set the files we have seen here in the actual solution. So when adding or removing, for example, changing a property, adding a new method, whatever, in a context of updating a to-do item, I will have to jump around between all these files, and they are in the domain, they are in the web UI, in the application. So you are constantly jumping around between several code files. You might have open at least 7 tabs. And yeah, that's quite a problem. So that's where I ended up and thought, what if MVC could look like a bit different? Because, as I said, model view controller first just says you have a model, you have a view in the controller. It says not how do you structure it. And that's where something different comes in. It's called vertical sliced, and it has been invented by Jimmy Bogart. I guess it's been 2018. A member of the .NET community, and he has also been a member of AlterNet community in the early 2000s when people started to question stuff Microsoft did in .NET and build their own stuff. Yeah, that's a different approach. So how does it work? Instead of saying, okay, I have that code that's scattered everywhere, and it does the same thing across different files, I'm saying, okay, I have code that belongs together. For example, updating an to-do item will be closer together. Or code for creating a to-do item, removing a to-do item, whatever. So you get several slices in your applications. And it's the scope of a feature, as you can see. So I can create, update, remove to-do items. And then there's one more step. What if I say that I put my pattern inside a slice? So I can say, I can have something like switch here inside every slice, as shown here. But there are more options to it. I can say, okay, my first slice might be implemented using MVC, using switch architecture, and my second slide, for example, can be a simple transaction script. And then the third slice can be something completely different, which matches my problem. So I look at my context, what might be the best solution for it, and the slice is implemented that way without affecting another feature. So you can live side by side. If we look at our to-do application, which has been with about 8 projects, and we put it into a single project, and we have a features folder, and below that folder we have our features, and then we have our update to-do item, for example, and we include these 7 files into this folder. There is a better cohesion now because that code that belongs together is closer together, and also locality of behavior is already much better. So how will look our controller right now? And I want to make a little switch towards our presentation. And this example now will switch to having products because everybody has some sort of product in some way. And that's our controller that will add a new product. So as before with the to-dos, we have a view. That's the first one where we can render our form, for example, and say, okay, you can add some details about the product and you can store it. And once you have clicked on the save button, the product will actually be saved. The key is that's all about that controller. It does one thing, it adds a product. So there's no update, no delete. You look at that code and you grasp it. That's all. And then we also have a different model. The model will be smaller, it will be more concise, and what's also important, we will have different models for different contexts, or we might have multiple models for different features, and that avoids property creep across the solution. So as I mentioned before, at the to-do application, there's a problem when you add a new property. Your model grows, and somehow it's getting bigger and bigger and bigger. And that model isn't just a model. It should be a representation of your domain. And somehow you want to have a state that's always valid. So, but if you have a lot of properties, you end up and have that problem that you need to know, okay, the property A and property B is valid when it is in this state. And then it comes in property C, and suddenly the status of A and B is invalid in some cases. And that's an issue. So how can we get to a state where the model is smaller and more concise, and these other requirements are fulfilled as well? And one way to achieve this is using event sourcing. And the models we have in event sourcing, I'm speaking of models right now, is commands, but they don't really matter that much in event sourcing. It's just to mention where the intent to do something comes from, and that's a model as well for me. And then we have events, and events are in past tense, and they state what happened, and they are small. Not always, but most of the time, and you should strive for it to keep them small. And then you have an event stream. So it's a history of events for an aggregate. What happened? Okay, product has been listed, for example, if you think of a catalog. And then that's where an aggregate starts and comes to life. It's the beginning of the life cycle of that aggregate. And then you can say, okay, the name changed, for example, or the price has been increased or decreased. And all these events run under that stream for that particular aggregate. And then you have projections, which are read models or write models, and they are based on the events on a stream. That's pretty much it about event sourcing. And there's been written a lot about event sourcing. There's also been said often it's too hard. People don't tell the truth about it. It's more complicated, which is true to some extent. If you're building a real world application using event sourcing, you might need more than just a left-hand fold. And that's something I have been looking at around 2020. What's the state of event sourcing in .NET? And I came across MartinDB. MartinDB is an event store built on top of Postgres. It's about 9 years old now, so it's quite major, or pretty major, I would say. Because it's being built on top of Postgres, you can have strong consistency if required. That means if you are persisting an event and you're building a projection based on that event and it's happening in the same transaction, which you can configure, that projection will be consistent with the events. That's something when you are new to events, you often hear it's eventual consistency. So it makes things a bit easier sometimes. You get versions of your events, and if you like it, pretty easy on your projections, which makes things a lot easier to reason about. when you're looking for bugs, for example. So Martin has projections. It had several types of projections. So you can have, for example, single stream projections, which means you can refer to the events of a single stream, or you can have multi-stream projections, or you can have custom projections. So there's a lot to it. It supports concurrency pretty well. And one of the key features to me is also the multi-tenancy model that has it built in. So you can have the classic with a column that has a tenancy key, for example. You can have different databases for different tenants. So it's pretty major at this point. And what's important, it doesn't make sense to have everything to be event sourced. And that's the other cool thing about Martin. Martin also comes with a document store. That's the store actually where the projections are stored in. And that's a document store. So you can use it the CRUD way you're used to, for example, from Entity Framework or maybe in Hibernate. And so you can have stuff that's not, I would say, much, for example, collaborative in the domain, or it's something basic, very basic in your application. You can just use a CRUD model to persist it here. And as your application grows, as you are learning, you can move on towards more event sourcing, or maybe less, if it makes sense. So how does it look like? It's pretty easy. So we have a record, product edit. Edit actually is quite of an anti-pattern because it says all or nothing. Maybe there's a better naming for that when you knowing more about your domain. So maybe, as I said, product listed, if you think of a product catalog. So you start listing that product in the catalog. And maybe that's the beginning of the life cycle. Then we have a ID for the product. That's actually not required, but you may want to publish an event to other services, to some external stuff, for example, or maybe other parts of your application. And then you might want to include that ID into the event. And we have a product name, for example. And then you can say, okay, I have another event, its product name changed. Again, it's great. You can see here it's not used from the screenshot, and it has a new name, for example. And then we have our product record, which of course has an ID because the document, that's the actual JSON document that's stored in Postgres, has an ID and it has a product name. And then we have this product projection, for example. It's a single stream projection of type product. And there's a conventions that you need to have a static method, for example, named create, which returns that aggregate, let's name it that way, or projection. And it's based on this event product edit. And then we are saying, okay, we are returning a new product, and that's it. And if we register this projection, it will start persisting product projections based on product edit events. And then we have another method, apply. And this will apply our product name changed event, and we can require Martin to give us the current state, the current version of that persisted projection. And we can change the product name because that's what we did in the event, and we want it to be reflected in our projection as well. So that's all we need to do event sourcing in .NET with Martin. For the beginning, of course. So when we look at our solution again, and think about vertical slices again, we can have a solution which looks like, or let's first say we wanted to have an application that might look like this. So we can have context which maps to bounded context from domain-driven design. And there's this thing called catalog, as I said. So that's where products, for example, come to life. Again, we want to list a new product in a catalog. And then we have some features like add a new product. And instead of having multiple files, maybe we can also put everything into this single file add product. And it would be great if you could also add our razor views within the same folder. And then there's some stuff we can add around this product, which is in the catalog. We can say, okay, we can add an image for that product. We can get the product image. We can get products. So a list of products, the actual catalog, for example. We can get the product title if we need it somewhere, or we can rename the product. And then we have another context, which is named sales. It has some features as well. And we can say, okay, we can get the product price, or we can price the product. So we can say, okay, that's the price of this product. And we can have furthermore context. So we can have shipping, warehouse, whatever. And then you might say, okay, that sounds great, but we have been doing sparse for a long time, and now our application doesn't have some reactivity. It is a server-side rendered page, and it's quite static. But there's a solution, and that's part of our views, how we can make reactivity a thing in a server-side rendered multi-page application. One solution, and it's my preferred solution, is using HTMX. It's pretty much like jQuery, which has been around in the early 2000s, and it's still around these days. But there's a difference. Every HTML element can trigger every type of HTTP request. And there are two packages, at least two packages for ASP.NET, where you can add support for MVC or Razor views for HTMX. But this is part of another talk today. It's the talk next after mine, one after the next. And now let's actually look at how this vertical slices thing looks inside code. So I will switch, and here's our solution. As I said, it's something e-commerce-like, and it actually consists of two solutions. And if we go here, we can see our contacts, catalog, and we can say, instead of adding or just saying add product, we are saying here add product to catalog. And as I mentioned, everything to add a product to a catalog is contained in this C# file. So there are no more files. And I have adopted a style I learned from F#. In F#, code inside a file or inside the solution can only be referenced from the code below. You cannot mix code together, which is not in that order. So we are starting with our model and say add product to catalog. And we are saying, oh, great message if you are doing something wrong. And we say that product, can it be sold? And we have a product name, but we don't have a price in here. And I will explain it soon, why we don't have a price on that model. So that's our model we'll be using in our Blazor views as our MVC model, so to say, to add a product to the catalog. And then we have a record product added to the catalog, as we have seen, which also reflects that can be sold information in its product name. We have the product name changed, and we have the actual product, which is the projection. And then we have our product projection, and this is a single stream projection of product. I just jump into the host configuration and show you its product. No, just go back. Let's use that. Here is it. It's in the event store configuration, which is called from the host configuration. And you can see we're just saying in our event store configuration, we will add some projection, and the projection life cycle is inline. That's what I mentioned earlier. If you want strong consistency, it's an inline projection. There are other types like ASIC, that means, as the name said, it will be eventually consistent, or live projection will mean it will be updated as you read the model, and the events will be applied during the read. So it will be slower than inline projection, which are persisted in the database, similar to async projection. So we will just stick with inline projection to make things easy at the moment. And then we go back to our product catalog. And we have our product catalog, add product to catalog controller. So how do we make the context a thing? And that's a context is defined as an area here, which is a feature of ASP.NET MVC. And to be honest, I have rarely seen it aside from being used for ASP.NET Core Identity, but we can use it to structure our application and say, okay, we have a context. And then we say, okay, our route is context, for example, catalog. And in that context, we want to add a product. So we have our add product to catalog model here inside our add product to catalog action. And then we have our subscriber store. I'll describe it soon, why it's called the subscriber store. And I have a message bus here. And then I say, okay, we will have a tenant ID, because my template is for building a SaaS application, which is multi-tenanted. So we already have support for tenants. And then we say, okay, the model state is valid at this point. Just create this event, create a session on the Martin event store, start a new stream of type product with the ID of that product added, which is a product ID, and add this event. And then we say, okay, save the session. It's like having the same as it's a unit of work that's persisted here. Okay, and then I say bastard publish async. I will publish that event. So where does that come from? Actually, I added another thing, and it's a message bus. Message bus is from Wolverine. It's a message bus library from the teams that made Martin as well. And of course, they integrate pretty nice. And you can have support for multi-tenancy in Martin, and it ties together with the multi-tenancy in Wolverine pretty well. So we are publishing an event, and then we are saying we are using our HDMix library and say, okay, when our product is created, we want to redirect our user to the product catalog overview page. back again. And that's why we're not returning a view here. We are creating a status code only. And that's pretty much it. So why did I publish an event? And that's where another context comes in. It's a sales context. The sales context is the place where the pricing for a product actually happens. And that's why we don't have a price inside our product model in our catalog, because pricing happens in a different context of our domain. And that's where we start with our start product pricing handler. And that's another projection. Here is our projection type, and here's our projection implementation. So we have two parts. We have our product master data, if we want so, for our catalog, and we have our pricing data. And it can be managed in different contexts, and it's glued together by these events which are shared. So we have, as we have seen already, a create method. And the idea is, so if we have products, if you think of a company that's doing manufacturing, for example, you might have products you want to sell, and maybe so you're producing them, or you're buying them and you are reselling them, for example. And then there might be products you don't want to sell directly, for example, welding fumes, welding stuff. You use it, you have it in your catalog to be able to order it, for example, but you won't sell them. You will use them to produce something, and they will be consumed. And that's, for example, the idea of this thing. So you can say, okay, this product, if it can't be sold, it should not be part of a price list for our customer, because we are in the sales context. And then we have our pricing handler. And then we can say, okay, we want to do the pricing here. And then we can say, okay, we have a get price list. And then we can say, get subscriber events to ID from the user subscription. That's the multi-tenancy part. And then we can say, okay, the list contains our product pricing classes where pricing can be sold is false. And there's actually a bug I've just seen. And then we say, okay, we can view our list of prices. Something got lost here, but we can re-implement it easily. So we can just implement it in the database using while store lightweight session, and then we can say product edit, and then we can say from here, from the product edit to catalog, we can say we are creating a new event, or we can just use it. It's a bit of a hack. I will explain it right now. Events stream of our product pricing, and we can say edit to catalog .id and edit to catalog, for example. Just let's do a new event to make it sure. Edit is equal to idea. It's equals edit to catalog, and then we can say destructure it. We can say okay. Here, product name, and can be sold. And Added. So what you have maybe noticed is the writer full line completion, which is some sort of local AI inside writer. And that's another nice side effect of having code in a single file, code that belongs together, because these single line completions work best in the context of a file. And if you provide the whole context in that file, it can get the most out of it. Okay, and then we say session, the changes, they changes async, for example, and that's it. And then the handler will save our product pricing, and we can say it cannot be sold, and we say, okay, it should be able to be sold, and that's it. So that's where we have our two contexts glued together. I said it's quite of a hack because you might not want to publish the event when we edit the product here directly. Maybe you want to have an event that exposes less data or different data. And you might want to have a different event than here to create or start the product pricing. So you have to think about it a bit. Another thing is I have used this iSubscriber store. So normally you are using an I document store, and that's a out of the box store for event sourcing in Martin. iSubscriber store actually is a marker interface to say I will have another store. Think of it like you would have different DB contexts in any different way, for example. So you can have an application which has multiple stores. So you may want to not use iSubscriber store here and instead have a sales store, for example, and you may have a catalog store. So these two contexts are completely isolated in terms of the storage. So each context, each service, if you would like to say that way, have their own store. Okay, so it might be that it's unable to connect now because we have rebuilt it. So that's our application actually, and we have a catalog and a sales contact. And because ASP.NET Core application, the product that I already added, doesn't have or can't be sold, maybe because it's not ready yet. It's set to false, and that means it will not show up in our sales price list. And if I would add a product, so it has said can be sold to true, it would appear at sales. So, okay, let's go back to the slides for a moment. As I said, I didn't mention Wolverine upfront. And here's a little overview about Wolverine. You can find more about it on the website. It's a command execution library, asynchronous processing library, messaging library, whatever you like. And it has an in-memory message bus. So you're not required to start with, for example, message brokers like RabbitMQ, SQS, or Azure Service Bus, but it's supporting them pretty well. And as I said, it has Martin integrations, and that some more integrations. So you should definitely look at it. So let's get back a bit to some theory. And it's, again, JetBrains did a poll 3 months ago and asked which of these activities is the most time consuming for a developer. And people actually said understanding code is the hardest problem of all of them, or at least of them that are listed. Almost 50% said that. And just yesterday, JetBrains posted a follow-up where they posted a study how developers spend their time, and another one measuring program comprehension. So how well and how easy or how hard is it for developers to understand code? And the studies are also linked. You definitely might want to read them. Some of that works that contained in these studies looks quite similar to another diagram I have seen in a book a few years ago. It's Idea Flow. And that book says, so the book is about handling pain in software development or making it visible. And it says, how do developers work? So when you are getting into a new code base or you're trying to add a new feature or whatever, you have a phase where you, or phases where you learn, you have phases where you make progress, and of course there's troubleshooting when things don't work as expected. So a day of a developer could look like this, or maybe completely different. But so you're learning something, you're applying the learning, you're learning something more. Learning does not only mean learning the code, learning the business rules, for example, then you are applying it. And then, oh, it doesn't work. You are learning again, make a little change, make progress, and then comes the next obstacle. That's how we do it. And yeah, if we think or compare our two solutions that we have seen now and think about navigating the code, what's easier? The traditional way of having a lot of controllers inside the controllers folder, maybe even in another assembly. The same goes for views and for models, or have it close together. And in an ideal world, it's also named properly according to what the business does. So, as I said, list product on a catalog, or increase purchase price, decrease sales price, for example. That's names that you can look for. And if you have a tool like Writer, you can use name search for files, which almost works here, but also, of course, using property or class name search. And if you align your code close to the business, it's much easier now. But when we spread our across around contexts, we have another problem, because now we have our product information, like our image, like our title, in our catalog service, and we have our pricing in another service. But in our UI, we want to display both side by side. So how can we do that? UI actually is a place where we have coupling, and we need coupling, because otherwise we couldn't couple things together. And there are two methods to do this. One is view model composition. So you compose the data and create views based on it. So your application UI knows about the view models and how to use them, or has an opinion how to display them. Maybe speak also of it's our brand. or you can have view composition, and a context can return a view in our shell, application shell, if you would like so. And we want to look at view model composition, how it can be done in the beginning, and how maybe you might evolve it over time. So I will just go to my terminal and stop our application. Looks like I need just look at view model composition. Okay, just starting it again. Okay. Okay, there's a little problem. I will just create a new tab.
Hey, Alexander, sorry,
Yeah.
we're just quickly dropping in. We are
Yeah.
running out of time, so we will have to go for the handover here. Are there any last things you want to mention as part of your talk?
Yeah. Okay, so I will just show the demo from Rider directly. Is that quick?
Yeah, go for it.
Yeah. Okay. So we have our view model composition here, and it's another solution here. So we have some interfaces here, which I provide view model data, which is implemented inside a bounded context, which can provide model data, and there's another one which can collect view model data. And both have only one method. So one can provide view model data async, and they can collect view model data async. And I collect view model data async is actually in our get products controller. If we look at here, and it says I'm the data collector for a view model, and what I'm getting is some product IDs. I have mocked it here a bit, so I'm just saying, okay, you have some predefined goods. Actually, that would be the products from your database, and we get our product quick info data, which is our composed view model from different services, and then we will have a loop over our product IDs and collect the composed view model from our interfaces which are implementing the provide view model data. And then we will add this data and we'll display it in our get product view. And the same we can do. So we are just displaying our product name, for example, here. And if we do the same on get product, we are doing something quite similar. But that time, we will include our unit and price information, which comes from another service. So one time we have our get product master data, which will just contain name and unit of that product. And when we are going to provide sales data, that will include the pricing. So that's how we can compose our view model together. There's a product sales data quick info provider, and the same is for our product master data. And these providers will be registered its scoped services. So if we want to, they could also access the HTTP context, for example. So they can live in the same assembly, but they could also access another service outside our context, application assembly outside our view assembly, which is our MVC assembly system. So that's how we can do composition. Of course, if you have a lot of data and you are going against the database, that might get slower, and you might want to mitigate it, either be it using caching, or you may sync data using, for example, change data capture to have some sort of read-only copy in a particular service and make set service the one set serving the actual view model. So there are different ways, and it depends on performance, on your structure, and a lot of other things. But that's how you can compose view models together if you are structuring them or spreading them across multiple boundaries.
Okay.
Yeah.
I'm afraid we're going to have to jump in there and leave it at that. Thank you very much for a fantastic talk there. There's been a lot of comments in the chat. I don't know if you want to join in the chat there. There's a lot of comments going on. A lot of love for MVC as well. A lot of people
A
still
lot of
liking
people
MVC.
looking for samples and how they can use this as well. So if you have links to share, blog posts, articles, and so on,
Yeah.
it would be very great to have you in the chat there.
Okay, so I will jump to the end of my slide. So I also have a bit of why I like it. It's about tech helpers. So they are more powerful than the documentation says, I would say. There's some stuff about REST APIs, but here's a slide. If you want to follow up on that topic, you can connect on LinkedIn or join me on X. There's also a Discord channel where you can join me, or you can just drop me an email if you want to. So if there are follow-up questions, and of course, I will provide samples for view model composition and for the vertical slices architecture using MVC, including that little part of event sourcing and the messaging, which is in memory here, but you can easily extend it to whatever you like, e.g. Revenue Kit.
That sounds fantastic. Thank you. We'll make sure those links are shared in the chat there. And once again, thank you very much for a great session.
Yeah, thanks for having me.
Absolutely.
Okay, thank you.
Thank you.